Okay, so this presentation, Graham replacement, and we're replacing everything, CPU, GPU, storage, and the cloud in the Graham data center is all being refreshed. Okay, so what are we talking about today? Why are we refreshing Graham in the first place? I mean, anyone that's doing HPC should know why we're replacing Graham, but let's just talk about that a little bit. How the refresh is going to be done, what the user experience is going to be. So this is a key bit. What are you going to notice when you're logging into the new system and interact with the new system? And then what benefits we're going to see from doing the refresh. So there we go. A little bit about Graham, the original system. It was built in 2017 at the total cost of about $25 million for that project. That involved renovating the data center, creating a brand new data center, in fact, for where Graham was installed, and then all the IT, all the compute hardware as well. We did a single RFP for the cluster and storage, and we did a separate RFP for, single RFP for all three components, cluster, storage, and cloud. And Huawei was successful in that competition. So that's what we ended up deploying. Oh, and I've got a comment on that picture. So fresh and clean and so nice. I really like that picture. The data center is not quite in that state right now, and I've got some pictures of what we're looking at right now with the renovations going on later on in the slide deck. Okay, so why refresh? I mean, if you're in advanced research computing, high performance computing, you know why we're refreshing. 2017 is a long time ago in terms of compute. But the good stuff for Graham, it was number 96 on the top 500 list back then in 2017. So one of the most capable computers. Over its lifetime so far, it's run about 90 million jobs. It's been used by over 4,000 research groups across the country and 15,000 different users. It also has attracted extra investment into the site, so about another $5 million of hardware has been added to Graham over the past 7 years. That's some direct funding to SharkNet and Waterloo to add nodes. There's also researchers coming with their own grants and adding extra new hardware to the system. So this has all been, very good news and a big success. But the bad about Graham and the system, we've had a very unstable file system or systems, especially the last little while, but almost from day one. Scratch and Project are Lustre-based file systems. And certainly recently, there's been a far more stability issues and performance issues. So, and when the file system is underperforming or unavailable, it really impacts the ability to get any work done. And then just overall, just not enough resources. It was a big system at the time, number 96 on the top 500. But research demands have continued to grow. More and more users are logging in. So we just need more resources. And then it's also burning through, it's consuming about $700,000 a year in electricity costs. And then on top of that, we have an additional bill of about $150,000 a year for the cooling required to cool off the system. Basically, all the electricity that goes into running a supercomputer or like Graham ends up coming out as heat. So you have to pay, traditionally, you've had to pay to get rid of that heat through cooling solutions. It's already 2 years past its best before date. Ideally, we're refreshing systems every 4 years. Realistically, it's 5 or more, and we're at year 7 for Graham. So it's definitely beyond time. Under bad, I put politics, and that's related to the vendor that was involved in the project. I've been a great vendor. It was great hardware we installed, very supportive vendor, but there's been issues. Anyone that reads a newspaper knows about issues with that we've been seeing over the last few years. And the other part bad is that there are going to be times where there's limited resources during the refresh process. So at times we're going to have to turn off parts or all of Graham while we're doing work in the data center and bringing up new stuff. So that's an unfortunate reality. We are keeping it to a minimum. And we will be posting on the status page and the MOTD and wherever else makes sense when we know about these outages. It could be that the power needs to go down for just 10 minutes with little notice. Unfortunately, that means everything's going to die. Or it could be that we're going to have a week or more outage because the cooling is being worked on. But we will communicate those as we are able to. Okay. So the replacement process. How did we get here? Back in 2022, there was a funding call from the Alliance. They've had money for refreshing the entire national platform. So this is all the systems. I'm only talking about the Graham refresh. I think it's for the other sites to talk about their projects. But Arbutus, Cedar, Niagara, Beluga are all being refreshed in the next little while, as well as Graham. So a 2022 funding call, we were able to secure about $50 million for this project. That's coming through ICED and the Alliance, with matching money coming from the province through MCU, Ministry of Colleges and Universities, as well as some significant funding from the University of Waterloo. Ilias asking about Narwhal. Narwhal is the newest of the national platform, so it was not scheduled for a refresh. So Narwhal is not part of the big project. So about $50 million for the entire project. And we only have about a year once everything was all finalized to get it done. The challenge with systems this large is making sure the data center can support it. And until you know your funding level, you can't really get started on the renovations, because if we were only able to secure $20 million, we wouldn't have needed any renovations to the data center. If we secured the 50 million we did, then there's renovations required. So until we know the funding envelope, it was very hard to get started on the renovations and the overall project. But once we had that number, it was full steam ahead. We issued an RFP, awarded it to vendors, and got the renovations started as quickly as we could. But the key point here is that it was such a compressed timeline, we just did not have the time to go out to the research community and discuss design, future needs, things like that. We basically just had to look at how the systems were being used now, what kind of demand we saw in the future for shape of jobs, that sort of thing, and then go to market to try and get hardware to address those needs. Ideally, we know about the funding years in advance of having to spend it, and we can do research or consultations, do a proper design, a more in-depth design on the overall system, and then go to market and get it deployed. But the timelines for this project were just so compressed, we weren't able to do that. And the reason for the tight timelines is that the money, like any grant, expires at the end of the grant. So once we were able to secure the money, we have a definite drop dead date where the money disappears. The grant is over. So we have to get everything done before that. Okay, so after the refresh, what's it going to mean for our user experience? A new Graham. I should also say we don't have a name yet. So if you're waiting to the end of the deck for the big reveal, it's not coming in this presentation. It's being discussed. Right now, we're just calling it the new Graham or Graham 2. But the user experience for Graham 2 will have all the same interfaces. So how you're interacting with Graham, you'll be able to do the same thing with Graham 2. So the main connectivity is through SSH with the MFA solution. That all stays the same. The CVMFS software stack has remained the same. So all the software already provided on Graham will also be available on Graham 2. We're continuous Slurm for the job scheduler. So all your job scripts, everything else will just continue to work. You'll probably want to modify them based on the hardware that we're going to be running on, as opposed to running on Graham, but they'll all continue to work. Same in file systems. So you're comfortable with Home Project Scratch. You'll continue to have access to things called Home Project Scratch. We'll talk about how they're a little different with Graham 2, but all those directory structures, paths, and everything else will stay the same. We're going to continue to do scheduling by core on the CPU nodes. So no changes in really the scheduling design. Globus, if you're using Globus for file transfers, is still going to remain. But it'll be an overall better, fingers crossed, it should be an overall better experience with the new system for a number of key reasons. The new storage is all flash. We don't have any spinning disk on the cluster side. With the refresh, it's all going to be solid state flash storage. There'll be over the years, we've heard complaints about how long it takes for test jobs to turn around, short running jobs, things like that. So there will be a larger interactive and development partition to get that type of workload through more quickly. Just overall more resources. So we are going up by about 4x in terms of CPU, in terms of cores, and about 4x in terms of GPU performance. We're not able to go up in terms of 4x in terms of GPU devices because each individual GPU device is incredibly expensive. So the new GPU devices are far more capable than the P100s and the V100s available on Gram, but we are going to have overall fewer devices, but about a 4x in terms of computational power on the GPU side. And we're going to have finally modern tightly coupled GPUs. So when we deployed Gram, the P100 was a good GPU, but the GPU landscape changes very quickly. So it quickly became an old generation. Then the V100s, we have some T4s, we have some A100s on Gram, but we're going to be deploying H100s on Gram too. Okay. So our project partners. This time we did the procurement process a little differently. We did purely a storage RFP to begin with. And because we wanted to get best in class for storage, we didn't want to get one vendor deciding to partner with a specific, any specific storage vendor that they saw fit. We wanted to pick the best storage for us. So we did a storage RFP independent of everything else. And VAST was successful on that RFP. So VAST is a modern file system. You may have heard it. They've been in the news for a couple of large wins. It's all flash. We're going to have 25 petabytes of usable space in the new VAST storage, and it will be providing home, project, and scratch all on the same infrastructure. And it comes with a whole bunch of more features. So one of the benefits of VAST, consistent performance, regardless of large file streaming, a whole bunch of small IOPS, independent of the use case. It's got good performance. It's all flash-based, and it has a lot of extra features like snapshots, where we'll be able to just take a copy of the file system and be able to restore files and roll back files easily in the short windows instead of waiting for a full backup of the entire file system to be done. So lots of nice features from VAST. The cluster was the next RFP that we issued, and Hypertech out of Canada was successful for the cluster RFP. Their bid was Intel based with Granite CPUs. So the nodes are going to have 192 Granite Intel cores per node and 768 gig of memory. They included NVIDIA H100 80 gig cards in their bid. And their bid was a little unique in that we were going to get 8-way H100 boxes. So these are going to be incredibly capable boxes with 1.5 terabytes of system memory. This is all going to be tied together with Ethernet provided by Nokia, 200 gig to the node and 400 gig core in the Ethernet fabric. And we're going to have a few large memory nodes with 6 terabytes of RAM in those nodes for workloads that require very high density, very high memory usage. And on the cloud side, we went to market and with CDW and Dell for the cloud solution, all new infrastructure, everything cloud related is also being decommissioned, and it's going to be a brand new cloud. more Ceph storage in total, more compute resources, and we will migrate all existing cloud projects from the current Gram to the new current Gram cloud to the new Gram cloud. Those are our partners that we've been working with. In case you're interested, the network diagram, high-level schematic of the cluster. Good question in the chat there about access to the internet, because this is the fabric. So there are pros and cons to having compute nodes talk to the internet in general, just anything in the internet or specific things to the internet. Being all Ethernet, it'll be a lot easier for us to manage that access. And right now on Gram, compute nodes can get to the internet to talk to licensed servers, to talk to specific services on the internet, but we don't allow just going a compute node talking to anything on the internet. It is locked down. We're going to continue with that policy, but we'll be able to open up to more things. So just if you need access, your compute node needs access to the internet for a reasonable reason, open a support ticket and we'll be able to create those rules to allow that access. Yeah, so this is the layout, spine and leaf design on the Ethernet fabric. The key bits, I guess, are that the storage and the GPU connectivity is all redundant. So all the storage nodes have multipath into the fabric. All the GPU nodes have multipath into the fabric. The compute nodes don't. It's just there's 700 of them, and connecting every compute node to multiple leaf nodes just isn't realistic. Backed up report replacement. Okay, I'll talk about data in a second. Let's see what else about this. So yeah, redundant connections for all the critical stuff, the login nodes, the storage, and the GPU nodes kind of get it by default. And then the compute nodes will just have a single connection each. Yes. So 700 compute nodes with 192 cores each. It brings us to about 135,000 cores. The GPU nodes, only 36 nodes with 8 each. So are getting a total, yes, of 288 H100s across the GPU fabric. 10 large memory nodes. Those are the ones with the 6 terabytes of memory. A whole bunch of login management nodes, and then the VAST storage nodes, providing all the storage. The interesting thing about storage is the VAST installation is taking up less than 2 compute racks for 25 petabytes of storage. And we're pulling out 6 project racks, another 6 scratch racks. So we're pulling out 12 to 15 racks of spinning disk and replacing it with simply 2 of the flash-based storage. Will anything need to get backed up before replacement? I'm going to address that actually when I get to the call to action. I do have some requests to the research community, so I think I'll talk about that when I get to that slide. Okay, so there's the layout. And if you have a big display or keen eyesight, you'll notice on the left it says immersion tanks. So this is the other interesting part, very interesting part of the project as far as I think very interesting. The renovation highlights. So as part of this, we had to do some renovations. Systems of this size generally don't just go into a data center. You have to make some modifications. So over the past 2 months, we've been doing substantial work in the data center. 2 key components. We're bringing in more power. The current Gram is pulling 700 kilowatts of power. The new system, we're projecting it to be 1.2, 1.3 megawatts of power required. So nearly double. So we have to bring in more power. Just the data center didn't have enough. And we're going to be going with warm water cooling. So instead of cooling with cold water, chilled water, we're going with warm water. So we're going to deploy the compute nodes in immersion tanks. Nice picture on the right there, where the server goes into a vat of mineral oil type substance, and that's where and that's the substance that pulls the heat off the server. And the GPUs are going to have direct liquid cooling, so that we're going to bring the water into the rack, right into the components, um, and cool the GPUs and CPUs that way with a warm water loop instead of a chilled water loop. And the benefit of using warm water is that it's going to substantially reduce our operating costs. Instead of paying money to generate cold water, cool water, we are actually going to be using the warm water. So HPC, I've said for years that it produces two things. A big HPC cluster produces two things: science results and heat, and it's very good at doing both. So traditionally, we've been paying to get rid of that heat. We've been putting more energy into chillers, things like that, to generate the cold water, which we needed to cool the system. Now with Gram 2, we're going to be using that warm water loop and sending our warm water over to the next door building, the QNC building, quantum computing building, where they have a year-round demand for heat. So we're now not only not paying to generate cold water, we're actually getting a benefit of the warm water that we're producing. And the numbers, our cold water loop was running at 20 C, and we're sending it back about 25. The warm water loop will be running at about 30 C, and we'll be sending that back at 35 C. And that makes it more usable for building heat or other uses. So very excited about that project, and that is well underway and should be in place for day one when Gram 2 gets turned on. Okay, and then a little bit about timeline. I put optimistic in the slide title because I'm generally very optimistic, and I hope we're going to hit these timelines. These are the timelines we're working towards, the milestones we're working towards, but things happen. So I expect this will slip a little bit, but hopefully not by very much. The one box I know for sure is October, because that's basically happened. The storage will be delivered and the cloud will be delivered, and that has happened. The VAST storage is already on site and has been racked up. It hasn't been commissioned yet. We don't have the file system available yet, but that should be happening in the next week or so. In November, the renovations are supposed to be substantially complete by the end of November, and we're going to start the storage migration. So here I'll talk about backing up data. The goal is that we bring up VAST as an alternative Scratch on Gram, just so users can start interacting with it. We can shake out any bugs and get the file system performing well. And we will start the migration of all data from existing project over to the new VAST project. We'll ideally do that during outages. So if we have to turn off the entire cluster and there's no compute happening, then we will be pushing data as fast as we can off of project onto VAST. But right now, we don't have a good estimate on how long it's going to take to move. There is almost 20 petabytes of data on the project file system, which we need to move over to VAST. So it is going to take a little while, but the storage migration will be starting in November. Home will migrate home, and that'll be easy. It's about 100 terabytes. That'll happen quickly during an outage. And then when we come back out of the outage, it'll just be the same files just being served up by the VAST file system. That's happening in November. December, we're going to have to shrink Gram. So Gram has already lost hundreds of compute nodes as we've had to turn off and free up some rack space. But it's going to substantially shrink in December because we have to free up significant footprint for the new GPU nodes. The new GPU nodes, H100 nodes, will be delivered in December. We'll keep Gram running as best we can. We're calling that a Gram 1.5. It'll be as much of Gram as we can leave running while the GPUs are being delivered. And in December, the cloud hardware will be installed. In January, the GPU nodes should now be installed and commissioned. They'll be up for testing. And this is when we're expecting the CPU nodes to be delivered. And in January, the new cloud should be going into production. And then in February, the GPUs are now in production. So the new Gram will be available purely as a GPU cluster in February. The CPU nodes will be in testing mode by then, trying to get them accepted, past acceptance testing. And the old cloud hardware will be removed and decommissioned. And then in March, the rest of Gram is removed and Gram 2 is in full production, ideally. Okay, so anything about backing up data before replacement, nothing has to happen on the user end, but ideally you would help us out, and I'll get to how you can help us out in the next slide or two. Okay, so there's the optimistic timeline. So what we talk about, Graham's been due for a refresh. We're finally getting around to getting it done. Overall, better user experience once the new system's in place, mainly due to just more resources, so less wait time in the queues, jobs will be pushing through, and also because of ideally better performant, more reliable file system provided by VAST. We'll be implementing some really cool technology with the immersion cooling and the direct liquid cooling. And we're going to be reducing our overall power and cooling costs by doing the heat recovery project. Okay. And then a call to action. How can research community help? So number one is clean up. We need to move 20 petabytes of data from project over to the new file system. And we ideally not be moving anything you don't need. So please, please, in the next little while, clean up files you don't need, reduce your footprint on project. That'll just make the entire project go easier, the entire deployment, sorry, go easier if we're not moving data that's not actually needed. And number two, engage our team. Please engage our team. The new hardware is going to come with some interesting new features. So on the GPU side, H100s far more capable than really any of the other GPUs we have. So talk with our team to figure out how to get the most out of these new resources. We're going to have a best practices document for the file system. VAST has a lot of interesting features. So it's all flash. It also does dedupe and compression at the file system level. So things like gzipping your files probably has no benefit and actually probably hurts the file system because now it's not looking at the raw data and doing its own compression, global compression. So we're going to have a primer on best use of a VAST-based file system. Just more resources, so shaping of your jobs, things like that, how to best utilize the queues on the new system. Please engage our team, attend any of the training, open support tickets, and we're here to try and get the system as optimal and jobs running as smoothly as possible. And then think big. 4 times as many cores available. So does that mean we're going to have free cores sitting there idle? Probably not. There's a huge demand. But now maybe your job, you can scale up to a larger problem. You can tackle something with the current national platform you weren't able to. So push the science forward, start thinking larger. Okay. Little bonus slide. I've been talking about the national platform. I don't want to, talk about the other systems and what size they're going to be and their schedules. I think that's for them to discuss and report back on. So just watch for those announcements. The Alliance site has interesting information as well. It'll be coming up. And then the other national systems are the PACE, Pan-Canadian AI Strategy Systems. So that's Amy out of the University of Alberta, Mila at McGill, and Vector Institute out of U of T. They're also deploying new hardware right now. And so watch for that. This is AI-focused hardware to support the AI institutes and member institutions. But it's just more hardware available on the national stage. During looking at the question here, during the transition, we're testing the new Graham, but maintain the old system. We'll license for software licensing. I think it should be available on both during the transition. Haven't thought about the software licensing side too much, but it should be available on both during the transition. All SSD file system can be effectively used for compute with large shared systems I/O on the system. VAST supports MPI I/O and parallel I/O, until we get it in place and really start kicking it around, we don't really know for sure how it's going to perform, but we're expecting good things, and I keep pressing fast that we better be getting good things with this file system. But we're expecting it to be very stable, very reliable, very performant. Limit of 10K jobs per user is something we're debating. It the scheduler starts struggling when too many jobs are sitting in the queue, so we have to. It's a balancing act between total jobs in and things like that. So the details are still being discussed. Transition K8's part of the plan. Okay, Kubernetes. So that will be possible on the Graham Cloud. At least right now, we're not looking at Kubernetes on the cluster, but the Graham Cloud will be supporting Kubernetes, the new Graham Cloud. Target date for cleanup. I don't know when our outages are going to happen yet. I have a meeting with the renovation team this afternoon. So I'm going to push them for outage dates and things like that. So we have a better idea when different things will be happening. And then we'll have a better idea of when the transition is going to be happening. So I don't know, start now, but ideally if it was done before the end of November, that would really help us out. Just removing files you don't need. CPU is going to be any faster than the current ones. So the new generation of Intel has some very nice features, better memory bandwidth, slightly different core, more features in the core. Are they going to be any faster core to core than the current ones? It's going to depend on the code. So ideally, yes. How much more? It's hard to say without looking at specific code you want to run. The other thing that we're hoping for is with the immersion cooling that we should be able to run in burst or turbo mode all the time. So while they are 2.1 gigahertz chips, we're hoping that we'll be able to run them at 3 gigahertz constantly because the cooling should enable that. But until we get the hardware on site, we don't know for sure. Okay. And then just some photos. I was on site yesterday, so just some photos of what we're dealing with. So to contrast that first picture of the nice clean Graham from day one when it was turned on to now, what our data center looks like. So on the top left, those black pipes, that's new water loop coming in to the data center right above the big UPS system. So yeah, mixing water and electricity very carefully. The top right is where they're welding up these new pipes in the data center with Graham running, because that's just where the work needs to happen. And we're doing this because we don't want to turn off Graham for 3 months and have nothing available to researchers while the renovations happen. It would certainly be easier, but it'd be far too impactful on the research community. So we're doing this kind of in a live working data center. Yes, we now have to put on steel toes and hard hats and safety vests when we go in to swap out a hard drive. But that's a small price to pay to keep resources available. Bottom left is just more of the piping. That's the main thing they're focusing on right now. And then the bottom right is the new mechanical room we're building in the data center where all the new pumping and heat exchangers need to go. And because of that has a potential for leaking, we have to dig into the floor to put in new piping to handle in the event of any kind of leak. So lots of renovations, lots of dirty work going on. But we're getting through it. And hopefully in about a month, the data center will be looking a lot better and ready to start receiving the new hardware.